Here's a physics nightmare unfolding in real time. 3I/ATLAS just survived a solar dive that should have killed it. Now it's racing away from the sun, getting colder every second. But instead of fading to black, it's glowing brighter, electric blue, the same blue you see in nuclear reactors. Scientists call it high-energy radiation. The problem? There's no heat source out there. It should be dead and dark. Yet the blue glow is intensifying. Is the core radioactive? Is something inside still running hot? December 19th, we get our last clear shot before it vanishes forever. What we find could answer the question no one wants to ask. Is this a comet, or did we just watch something with engines fly past Earth? Let's dive right in. Let me show you exactly what's happening right now and why scientists are quietly checking their data multiple times before saying anything publicly. On November 30th, Hubble locked onto 3I/ATLAS. By that point, the object was 1.5 astronomical units from the Sun, deep into the cold zone where comets fade and go quiet. The ice stops boiling. The show ends. That's textbook behavior. But when the spectrograph readings came back, something was wrong. The object wasn't fading. It was glowing brighter. Electric blue. The readings showed ionized carbon monoxide and nitrogen, elements that only produce that blue light at temperatures exceeding 3,000 Kelvin. At that distance from the sun, there's no heat source powerful enough to sustain those temperatures. Yet there it was, burning blue in the darkness. ALMA Observatory in Chile measured the actual gas temperature surrounding the nucleus. Sections of the Coma registered at 180 Kelvin, minus 93 Celsius. Still cold, but not nearly cold enough for an object that far from the sun. It should be approaching 100 Kelvin or lower. Something inside is generating its own heat, and it's not coming from sunlight. Avi Loeb from Harvard said what others were thinking but wouldn't publish. If the core contains radioactive material, uranium, plutonium, isotopes we haven't considered, the decay would produce exactly this signature. A sustained internal heat source that doesn't fade when you move away from the sun. Now here's what makes this stranger. This blue glow didn't appear randomly. The object went through a sequence, and sequences suggest process. When 3I/ATLAS first entered our solar system in early 2024, it was red. Deep, dark red, the color of surfaces bombarded by cosmic radiation for millions of years. Scientists saw that and nodded. Interstellar object. Normal. Then it dove toward the sun. At perihelion, it changed. Bright, vivid green. That's diatomic carbon burning off as solar heat activates the surface. Scientists relaxed slightly. Okay, it's behaving like a comet. But as it pulled away from the sun, heading back into deep space, it should have cooled and faded. Instead, it shifted to blue. Intense, pulsing blue. And it's been getting brighter. Think about what that means. Red is dormant. Green is solar activated. But blue means something else is happening now, something that doesn't depend on the sun anymore. The official explanation is that solar heat stripped away the ancient crust, exposing fresh ice that's now sublimating. But that ice should be sublimating slower as it moves away from heat, not faster. What if the sun didn't just heat this object? What if it triggered it? The Hubble images show something else that has astronomers questioning their understanding. There's a beam of material 40,000 kilometers long, pointing directly back at the sun. In comet science, we call these anti-tails, but they're usually optical illusions, tricks of perspective that appear and disappear. This one has been steady for 3 weeks. And here's what's keeping people up at night. The beam adjusts, As 3I/ATLAS moves through space, this spike stays locked on the sun. It compensates. For particles to maintain that trajectory against solar wind, they'd need to be several centimeters in diameter. But comets don't produce centimeter rocks in a focused stream. They produce fine powder that disperses randomly. This looks controlled. One explanation is continuous outgassing on the sunward side. But jets flicker as rotating surfaces face toward and away from the sun. This beam has been constant for 21 days straight. That's not how passive outgassing works. While Hubble watched the structure, ALMA analyzed what's inside that blue cloud. Methanol. Massive quantities, CH3OH, one of the critical building blocks for organic chemistry. This molecule starts the reactions that lead to amino acids, to the complex molecules that make biology possible, and hydrogen cyanide, HCN. Deadly to us, but in space chemistry, it's a precursor for adenine, one of the 4 nucleobases in DNA. Every comet carries some methanol and HCN, but the ratio matters. Most comets show ratios around 10 to 1, maybe 20 to 1. 3I/ATLAS is measuring 124 to 1. That's unprecedented. The only object that came close was Comet C/2016, R2 at 80 to 1. Loeb asked publicly what others were asking privately. Is this a serial killer bringing poison, or a friendly gardener scattering seeds? If you wanted to seed a planet with the starter kit for life, methanol is exactly what you'd choose. That 124 to 1 ratio isn't random, it's optimized. But there's a detail in ALMA's data not making the press releases. The methanol isn't evenly distributed. There are dense regions, and they align with that beam pointing at the sun. If this object is distributing something, it's doing it directionally. Then, on November 10th, Meerkat Radio Telescope detected emissions at 1,665 and 1,667 megahertz. Scientists responded quickly, it's hydroxyl radicals. Every water-bearing comet does this. Nothing unusual. They're technically correct. But there's a detail that doesn't fit. The signal is steady. Comets rotate and emissions should pulse as vents face toward and away from the sun. You get variations, flickering. 3I/ATLAS has been emitting continuously for 18 days. No pulses, no variation. The hum is constant, and those frequencies sit right in the water hole, the quietest band of the radio spectrum. If you were designing interstellar communication, you'd choose this band because it's where the universe's background noise is lowest, where any civilization with radio telescopes would be listening. Is it coincidence that this object is emitting in the exact frequency we'd use for interstellar communication without variation for weeks? Now the trajectory. 3I/ATLAS is on a hyperbolic orbit. It should be predictable, but there's a discrepancy. The object is experiencing non-gravitational acceleration of roughly 2 × 10⁻⁸ astronomical units per day squared. Small, but real and consistent. Comets do this through outgassing thrust, but tumbling comets create chaotic acceleration, wobbles, and adjustments. 3I/ATLAS's acceleration is smooth, linear, as if the thrust is directional and controlled. Loeb pointed out that if this were an artificial object performing an Oberth maneuver, this is exactly what you'd see. Dive deep into the sun's gravity, fire engines at closest approach get maximum acceleration. 3I/ATLAS dove to 0.04 AU, closer than Mercury, survived temperatures over 1,400 Celsius, and emerged moving faster than gravity alone predicted. Here's what's maddening. We still can't see what's underneath. The nucleus is buried under a gas cloud thousands of kilometers thick. Radar got fuzzy returns confirming something roughly 5 kilometers across, but the shape remains unknown. But on December 19th, the angle changes. The sun will illuminate it from the side. The coma should thin. James Webb will be watching in infrared, wavelengths that pierce dust. If there's structure underneath, Webb might catch it. And there's the debris field. Analysis shows 3I/ATLAS isn't shedding fine dust like normal comets. It's shedding gravel, particles 3 to 5 millimeters in diameter. Heavy enough that solar pressure can't sweep them away. They stay in orbit. The densest concentration falls along the orbit section from November 15th to December 5th. Earth passes through that exact zone in late 2027. Whatever this object dropped, we're flying through it. We have one chance. On December 19th, 3I/ATLAS reaches closest approach at 1.8 astronomical units. Every major observatory is scheduled. We're looking for the moment when gas thins enough to see through. We're measuring whether acceleration changes after passing Earth. We're listening for any shift in that hum. After December 19th, it's over. The object fades until even our best instruments can't track it. We either get answers in the next 11 days, or we live with questions forever. What did we just watch pass through our solar system? Here's what we know. 3I/ATLAS is glowing blue like a reactor while moving away from its heat source. The physics doesn't add up. The chemistry is optimized for life. The trajectory shows controlled acceleration, and the debris it dropped will be in our path by 2027. December 19th is our last clear window. Every telescope will be watching. We'll either see what's underneath that glow, or it fades into deep space with more questions than answers. If this gave you a new perspective on what's flying past Earth, hit that like button. Comment below. Comet or something designed. Subscribe to Galactic Breaking News and turn on notifications. December 19th, we're covering every data release live. When Webb's images drop, when signals shift, you'll know here first. The next video breaks down what happens after it leaves and why 2027 matters most. Don't miss it. See you on the 19th.